All right. Now we have a question again, and from here we are told that a constant force of 60 newton, okay, still under rotation of a rigid body. Now solution. Don't forget, always bring out the parameters. Okay, we are told that a constant force of what, 60 newton. So from here we are giving our force to be 60 newton. Okay, it's applied tangentially to the rim of a wheel, 40 centimeter radius. So we are giving our radius to be 40 centimeter. What do? You convert to meter by divided by 1000. So it's stating as 40 divided by, by dividing by 100. So we give us 0.4 meter. So from there we are told that the rim has the moment of inertia of what, 50 kilogram meter square. So which is our I, moment of inertia 50 kilogram meter square. So we're told to find number one, the angular acceleration. So that is A. We are looking for the what, angular acceleration. Angular acceleration is what, alpha. So for the B of it, we are told that the angular speed is stating as omega. Okay, they said after 6 seconds from rest. From rest, it simply means that we are giving our what, omega 1. So that we are looking for what, omega 2. So our omega 1 is stating as what, 0 rad per what, seconds. And we are giving our time to be 6 seconds. Okay, so from there, number C of it, we are asked to look for the number of what, revolution, which is our theta made on that 6 what, seconds. Then number 4, we are asked to show that the rotational kinetic energy, the work done on the wheel, is equal to the rotational kinetic what, energy. Okay, that is our W, which is work done, must be equal to what, KE arrow. If your work done here, the answer you got to your work done is not the same thing with what you get to your rotational kinetic energy. Simply that you're working, there is an error. You have to what, to cross check what you did. Okay, all right. Now from here, how do we get our alpha? To get our alpha, okay, now I'll just go straight to the point, because our alpha is normally is torque over what, inertia, or that rotation of a rigid body. Now from here, the issue then is that we don't have our what, our torque, but we have our moment of what, inertia. What you need to do, you have to look for torque. Since you have force and you have radius, our torque is equals to force times radius. So from there, our torque now will be equals to our force. Force is sitting as what, 60. Then times y radius is sitting as 0.4. So from there, torque will be equals to, so 60 times 0.4. So it's going to give us 24. 24, the SI unit is what, Newton meter. Now that we've gotten our torque, we can put it into this expression to get our what? To get our alpha. So from here, our alpha is torque over what, inertia. So which is equals to 24, then divided by our inertia is setting as what, 50. Divided by 50. From there, our alpha will be equals to 24 divided by 50. So which is going to give us 0.48. 0.48. So rad per second square. Now we succeeded in getting our what, alpha. So the next step now, we are asked to look for the number 2, which is the B of it. We are asked to look for what, omega, and we are given our W1 to be 0 rad per second, which is from rest, and our time is 6 seconds. Okay, now how do we get our omega from there? From alpha equals to W2 minus W1 all over T. Now if you cross multiply, making your omega 2 the square to the formula, you are going to have omega 2 equals to alpha T, then plus what, W1. So from there, omega 2 will be equals to, our alpha is sitting at 0.48. That is 0.48. Then times, our time is 6 seconds, then plus 0. So we're going to give us 0.48. 0.48 times 6. So it's going to give us 2.88. 2.88. Then plus 0. So our W2 is going to give us 2.88 rad per seconds. Now that we've gotten our W, so the next question there, we're asked to look for what? We're asked to look for theta, okay, which is the number of what? Revolution. Okay, now this time around, in looking for theta, which is the C of it, our theta is equals to W2 plus W1, then all over 2, then times time. So from there, our theta will be equals to W2 is stating as well 2.88, like 2.88, then plus our W1 is 0, then all over 2, then time, our time is stating as well 6. So if we add up this, our theta will be equals to 2.88 divided by 2, then times 6. 2.88 divided by 2. So it's going to give us 1.44 times 6. So our theta is going to give us 8.64. That 8.64 rad. So that is our answer. So the next step now, which is number 4 question, we're asked to prove that our work done is equal to the what? Kinetic what? Energy. All right. In looking for the number 4 question, so which is the D part of it. So from there, how do we get our work done? The formula for what they're stating as torque theta. Okay, we already know what was our torque, and we got our torque to be what? 24. From there, our work done is equals to 24. Then times why our theta is sitting as what? 8.64. So from there, our omega, our work done is going to give us 24 times 8.64. 24 times 8.64, we have 207.36. 207.36 what? Joule. So the next step is to get our work done. Okay, sorry, this is our work done. The next one is to get what? Rotational kinetic energy. Now our KER there is equals to 1 over 2 initial W square. So from there, our KER will be equals to 1 over 2 times inertia is sitting as well 50 times our W, we get to be 2.88 watts square. So from there, our KER is going to give us 1 over 2 is sitting at 0.5 times 50, 2.88 square. It's going to give us 8.2944. That is times 8.2944. So from there, our KER is going to give us, when we multiply everything, 0.5 times 50 times 8.2944. So it's going to give us 207.36. Energy is in what? Joule. Now, if you compare and contrast these two answers, which was that our work done, we got 207.36, and our rotational kinetic energy got to be what? 207.36. That have answered this very question. We were asked to show that the work done on the wheel in 6 seconds is equal to the kinetic energy of the wheel after what? 6 seconds. Alright, so that is our answer. Please subscribe. Thank you.